Hi all, I'm Liz Hoy of the NASA Carbon Cycle and Ecosystems Office supporting the Above campaign. And this is our series, the Above Science Cloud webinar series. We try to meet every third Friday of the month at 1 p.m. Eastern Time, although with schedules and summer field seasons, we don't always make it. And of course, today is November 30th, so we're not in our normal time frame right now. But we'll go ahead and get started. But as there are so few of us, why don't we say hi, those that are online, and this doesn't always have to be a very formal webinar. So I don't know, Eric, I see you're muted now. You're first in my participants list. Do you want to say maybe your name, affiliation, and how you use the Science Cloud? Or you can chat it in the chat box.
Is this working? Can you guys hear me?
Yep, we can hear you. Yep.
Okay, perfect. I'm Eric Sofferon. I'm associated with Conservation Science Partners, for a conservation analysis group based out of scenic Truckee, California. And previously I was working with Josh Fisher at JPL, who's the head of the Above Model Working Group. And my main use for the Science Cloud is the Above benchmarking system is hosted there, along with quite a few data sets used by the system.
Thanks, Josh. And then we have a few people from the DAC. I think Jack and I think you said Hannah, as well as Yashing is online.
Hi, yes, Hannah and Carol and Jack, we're all listening in. We're here at the ORNL DAC. We do some data support for the Above mission, but I think I can say that this is the three of ours first. So just listening in for informational.
Well, it's on. And then Sarah, where are you joining us from?
Can you hear me? Oh, great. Yeah, I'm Sarah Davidson, and I'm part of the Animals on the Move project with Above via the Ohio State University. And this sounded like kind of an interesting project, so I just kind of wanted to listen in and see how you described this process you went through. It looked like it might be relevant for some other stuff I'm working on.
Well, that sounds great. We're glad you can join us today. And we have a few people from NCCS, and maybe we'll start with Laura.
Hey, I'm Laura. I do a lot of technical project management here at the NCCS, working with Above for quite a few years now. Mostly just making sure that things move forward whenever I can help with that.
And Julian, you want to introduce yourself too?
Sure. Julian Peters. I handle data management for multiple projects, but a lot of it is NGA data, so I work a lot with the Above folks, and I just help people find where things are at.
And the NGA data is that high resolution digital globe imagery, less than a meter resolution. So Julian he's got his hands on all the data, and he does a great job keeping track of helping people find it. And so we're really happy to have Julian help us with that. And I think that was everybody except for our speaker. Were there any other participants? I don't think so. So we'll let Jim go ahead and introduce himself. I'll just say a little bit. Jim is the NASA Center for Climate Simulations principal applications architect, and he helps set up the Above Science Cloud. He does a lot of our work with Esri products and set up a nice portal so that we can have web services and web maps through the Science Cloud. And he's going to talk a little bit today about the workings behind a web map that we showed at our last one of these talks, which was back in September, and that is archived and online if you want to go back and look at it. So Jim, I'll let you go ahead and take it away and tell a little bit about yourself and what you got going on today.
All right, sounds good. So as Liz mentioned, I'm kind of the GIS person here at NCCS. So I try to stand up the platforms and enable scientists and partners to use the various portal and ArcGIS server tools that we have online. So today I'm going to, this presentation was going to be a smaller presentation piggybacked on last month's app demo that Carly Robbins did about the barn swallow climate story. I'll show you that app is actually available for review, so you can check it out. And I'm going to explain a little bit about how she got some of the time-enabled data that she needed for that app. So Liz, can you click the next slide, please? So the way that this project works is we have to basically set up the environment for what we want to do. We publish the actual time-enabled service before we have any data. The reason we do that is it's a lot easier to go ahead and publish it and get it ready and then just populate the data on the back end. Sometimes you have to modify the script or you have to modify the procedures when you notice that there's a mistake in how you're grabbing the data out of the multidimensional NetCDF files. We already have a script in place, and I'm going to spend a little bit of time kind of going through that to show you guys what's out on the Science Cloud now and show you where it is, and you can grab that script and copy it and repurpose it. I'll explain kind of how it can be reused. Then the script is going to basically take the NetCDF data and put it in the format that we need. And then at the end, I'll show you how the application gets created. All right, so go ahead to the next slide, please. So this is how the script works. It's basically all out-of-the-box Python stuff, but there are some other libraries that are in there. And then what we also do is we have some scripts that are run by the disasters team, and I'm trying to think of the other group. There's the disasters team does the majority of them. The landslide team, team run by Dahlia Kirschbaum, has some automated scripts. They all run through Windows Task Scheduler. So basically what this script does is it gets a list of all the images in the NetCDF file, and then for each image, it goes and checks the file, it downloads or extracts the file, and then it'll add it to the Mosaic data set. Then it goes in and updates some attributes, removes any old files from the file system, removes any items from the Mosaic data set that are no longer needed, and then it'll update the Mosaic data set path, and I'll explain that, what that means here in a minute. So I will go ahead and if you want to stop sharing, Liz, I will share my screen.
Sure, I went ahead and stopped.
Okay, give me just 1 second.
And while Jim gets that queued up, I see Matt McCander joined the line as well. Matt, you want to give a little intro real quick? Maybe Matt doesn't have himself off mute. Well, Matt works with, it's like ADR and is doing a lot of, he uses the digital globe imagery and I know does vegetation and tree work. So that's his intro.
Okay. All right, so this is the main NCCS page. I'll just show you where the climate story, story map is located. So if you just go to maps.nccs.nasa.gov, you give it a few seconds to load up, and there are some embedded applications, and the climate story one is the third application right here. A little lag on my screen there. And so you can either look at it embedded here in the website, or you can click View Full Application. If you do that, it takes you here, and this is just a standard Esri story map with some information about the study. But basically what this did is it looked for surface temperatures to see if there was any impact on the barn swallow locations. And then she ended up, Carly ended up taking the individual data and then making this video. It probably won't show too well over Adobe Connect, but you can click that when you're in the app, and you can see the result of the Mosaic dataset extraction, or the NetCDF extraction that we did. So you're welcome to look at that. So let's go in and talk about setting up the project. So in the Science Cloud, there is this, and you may not be able to see it, but it's ATT Project ArcShare Public. is a shared repository. So you can see everybody has their individual folders in here. The disaster response group, for example, has theirs by project. The scripts that I'm showing today are all located in this crobin2 directory. You're welcome to go in there and grab the scripts. But basically, here's what I did, right? So everything that's being exported is exported out to this directory here, this export directory. So I just made a copy of it called exports demo. We're going to look at CI's concentration. We put a couple folders in here. We have a logs, overview, rasters, and then our file geodatabase. I was doing some maintenance on the file geodatabase, so let's see if that's processed. All right, great. All right, so to look at the contents, we'll go back here and look at the contents of this directory. Bear with me 1 second.
While Jim looks for that, I did add
the
chat box. I added the barn swallow map if anyone was interested in going.
All right, thanks. All right, so what we have here is all of the resulting rasters are going to go into this directory, this rasters directory. I can't remember if this particular one uses overviews, but we do have an overviews directory that we kind of stub out. And then we have the Mosaic data set itself, which is this SIC. There's a feature class here, which I'll explain in a minute. And then I'll explain why there's an SIC web once we kind of go through everything. So the idea here is we get our project all set up, and let me show you the path of this project here. So where's the CI? This one. So the CI file was in DAS, which is the central data repository, but it has actually been copied to this Project ArcShare Public source data directory. So right here where source data is, that's where you will see a netcdf file. So let's go look at this, right? So you'll notice I'm in source data. It says the location is source data, but I don't see the netcdf file. The reason that this whole process even exists is because Esri doesn't really know exactly how to work with a netcdf file. And here's what I mean, right? So I will just briefly show you what's going on. So we look, when you're here in catalog, you look and there's no netcdf file, right? If I come back to the directory, I can see, oh, there's my netcdf file right there. So what happens is Esri doesn't have the native capability to read that netcdf file. So what you have to do is you have to make a netcdf raster layer, right? So what ends up happening is, you go in here and you say, okay, I want to make a netcdf raster layer. I'm going to copy the path to the file. Oops, sorry. Bear with me 1 second. Here's sea ice concentration. And then it'll go look at that and it'll say, oh, okay, my variable is going to be sea ice concentration, blah, blah, whatever, okay? So then I click this, and it's going to make that netcdf raster layer, but what time slice am I looking at, right? It never said pick your time slice. So who knows what time slice this is? So this is what I meant by saying that Esri has a little bit of a limitation with how they can read this data. So you end up having to go in and select the time slice here, or you have to go into the netcdf raster. So if we click in here, we should see all of the available time slices. So to make this netcdf raster layer, I can say, okay, I want 10/16/1979. Oh, I got to give it a new name. And so that's what sea ice concentration looked like in 1979. Well, that's great, but now how do I deal with this time series, right? So that's where the script comes in. So now that we know where our data is, and we kind of have our directory, we have our directory set up, right? What we need to do is go and look at the script. So again, this is in that crobin2 directory under scripts. This file is called SIC import. And so what ends up happening here, I will just I'll try and run through it quickly. But what we have is we have a couple of utility files that are also there. If I show this projects directory, you'll notice that under scripts, there's this classes directory. You're welcome to grab utilities general and utilities raster. And what they already have is some functions that are common. So for example, if you want to set up logging for your Python script, here's a function that'll do that. All you have to do is pass it the location of the log file. If you want to create a directory, here's a function that'll do that and then actually spit out an error if it fails. Importing from CSV. These files are already created and you are welcome to use them. And what we do in this script is we actually call those files so that we don't have to build these functions every single time. So let's talk about what this file does. The first thing it does is it captures the script parameters. So this is PyCharm. If you're not using PyCharm, I highly recommend it, especially in the Windows environment here at the NCCS. What we can do is this script is packaged in a way, or is written in a way, that you can do this for any netcdf file. I just happen to be applying the CI's concentration file to this script, but I can set all of this. So basically this is whether I'm in testing mode. So what testing mode is the limited number. If you don't want to have to go through 400 time slices, you just want to do the first 10 to see how your script works, you can set this to true and it'll do a subset of your images. This is the parallel processing. So for the geoprocessing functions that can utilize parallel processing, you can set that here. We try to recommend that folks stay under 40 or 50% so that they don't bog down the machine. And then there's the netcdf variable, the time dimension name, where the root directory is, and then also where the target directory is. So this is the demo target directory. And then the name of the netcdf file and how we want the image to come out, right? So that's the exported image is going to be a TIFF. Okay, so let's close this. The point of showing you that is that you can set your own variables and run this script yourself on another netcdf and it'll work the exact same way. So what we have, let's see, we go through when we're setting up the logging, doing stuff like that. Let's get down to the meat of it here. So this is where we spit back out the parameters in case there was an issue. We know where the master feature class is. But what it does is it makes sure that the Mosaic data set has a date field. And then it gets the list of time dimensions from the netcdf. So what it does is it creates a Python list, and then it's going to loop through that list of date stamps, if you will, and it will create that netcdf raster layer for the date stamp that we want. There's some kind of housekeeping things where it sets the extents so that this image doesn't shift. And then it will output a raster. So see how we have this netcdf layer? I can go and right-click it and say data, export data. And then I can make it a data raster data set or whatever, a TIFF file. See here, make it a TIFF file. That's what this step does. So it takes that snapshot of the time, and then it exports it to that raster TIFF format. And then one of the other things that I mentioned earlier, you'll see here we have this FC. That's the CI's concentration feature class. So what we're doing there, since we're already running this script that takes an hour or two to run or however long it takes, we're also converting the raster to a polygon so that we can do stuff like this. This is CI's concentration. Let me turn the looping off here. Give it a second to draw. But basically, this is a polygon of CI's concentration through the various time sequence. And what I did was I just projected it to a polar projection. And we can see that this is, let's see, 9/16/2018. That's what CI's concentration looked like. But by doing this, we can actually intersect this polygon with the raster or with other data a lot more easily than we could try to get the value from the raster and things like that. So now it's vector to vector analysis versus raster to vector type analysis. So we export that raster time slice to a polygon. And what we do is we put it into that master feature class that I just showed. Then we take the raster that we created, which is that TIFF file, and we add it to the Mosaic data set. And then it loops through that whole thing. So that's it. That's all this script does. There's a lot of stuff in there, but because we're using the list, it will loop through that entire list for us without us having to have any variations in execution. It's all consistently processed. We did notice with one of the other NetCDF data sets that there was a gap in a date, like July of 1 year was missing for some reason, and we actually sent that back to the analysts and said, hey, we're not getting data for this month, and we're getting a gap in the data, and they said, oh, wow, we found a problem, and they reran their analysis. So that's literally all that's involved with this script is setting parameters, and then as long as the workflow that you're trying to use follows this approach, it'll work. It'll just work for you. And so what we have is we have this. Let me go back here to the original one. So this is the one that's hooked up on the web right now for sea ice concentration. So we can see that we have our Mosaic data set with all of our images. System's been a little slow this morning, so bear with me. So we can see here's all the raster time slices for the TIFFs. If we go back to the directory, I'll show you how it exported. So here's the exports directory for SIC. This is the directory that we're looking at. So here's that GDB. Here's all the rasters that it created by exporting them out. Now, one of the things that we have, let me just explain this. So you see that where we have SIC web here. So what we've done in some of the disaster scripts is we actually have a step at the very end that rewrites the Mosaic data set path. And the reason is that the ArcGIS server is a Linux server, and it does not understand anything related to C:\\. So what ends up happening is, we come down here, a path like this in Windows, if you have a path in your Mosaic data set to a TIFF in this directory, the server will not be able to see it. So what we do is we create this SIC web. We basically copy the Mosaic data set when we're done, and we use update raster or Mosaic data set path to change any instance of this to what Linux understands, which is this ATT project. I think it's ATT ArcShare Pub, technically, is what the server would see. So that's a kind of a necessary step. Otherwise, you end up getting like red X's and it can't see the data. So here we can just see kind of the general data associated with this, but let's show it in action. So we already showed the feature class, and this is a time-aware feature class. It takes a little bit of time because it has to reproject it and whatnot. So we can see updates periodically here. But let's look at the data on the web. Where did I put it? Right here. Hold on one second. So here what we can see is that same SIC data set from 1979 to 2018 in a time-enabled web map. And because of the way that the projection works, it's only available in this Web Mercator projection, but we could go the extra mile and make it available in like a polar projection. But you can see that it's cycling month by month, and it's actually going through the data set. And this is a global data set. It takes a little bit longer to draw if we zoom out, but there is data all the way around. And you can actually see it creeping down over the winter and creeping back up as summer comes on. So it's pretty useful. So let's say that we have this data, and now we want to, I'm just going to save this demo map. So now that I've saved this web map, I can actually get fancy and I can make an application out of it, similar to that the barn swallow climate story. So this is what's called a story map. If we wanted a story map, we could do that. But let's see what options we have. Let's see, I have a compare map. Let's see. Let's just copy what she did. So we'll do the story map journal here. How about that? And we'll do the side panel. Story map. And this is where we would walk through and customize what we want to be on the page. So we're just going to quickly go through here. Let's see. And so now we have our web map that actually is embedded in this application. Now we can customize it, pick specific dates. We could make pages that focus on various dates in that Mosaic data set. We could add additional sections similar to what she did with this one where we used the surface temperature, not sea ice concentration. So it's pretty easy once you have the data formatted properly to go from the raw data all the way out to a time-enabled Mosaic data set, especially if you go ahead and start with these scripts that we already have that you can just grab and make your own. And I think that's it for now, Liz.
Thanks, Jim. So if you haven't gotten to see the whole barn swallow map, I put the link in the chat box. I'd suggest going and taking a look at it. And I think what's important to remember here is that, you know, Jim is available. We can assist you if you're interested in something like this. But it's actually, it's not as complicated as you might think to make these web maps and get them published and share them out with your users. I think they can be a really great tool for doing any kind of outreach work. And if you wanted to show some of your products to a specific audience that you're working with, it can be really helpful to do that. And there's a lot that's already embedded in what Esri has done that makes it pretty simple to set it up. So I'd encourage you to take a look at the barn swallow map, and you can look at our last webinar that we did to see another example where JJ Frost and Above PI created a web map using some high-res imagery that he shared with some students that he works with. So does anybody have any specific questions for Jim on this process? I know it's a lot to take in, but the goal really is to show you that this capability is there and that it can be used. He's got the example scripts that you can even pull from. So do you have any questions about this topic? If not, I have a couple other slides I'll show and we'll talk just more generally about cloud issues. All right, I'm not hearing questions, so I'm going to go ahead and share my screen again. Let's see. Okay. So without hearing any questions, I just wanted to have a couple announcements, and then I have some just general Science Cloud things to talk about too. One is that I'll be at AGU next week, and I hope to see you guys there. I'm giving a talk about accelerating science with cloud technologies in the Above Science Cloud, and this is in a session that Sengdar Lee put together. He's the, I guess, what is he, Laura? Is he the computing lead at NASA? I'm not sure exactly what his title is, but I would love to feature your research in here, Science Cloud users. So if you have recent research you've done with the Science Cloud, please contact me. I'd love to put a slide in there of what you have done.
Hey, Liz,
and
just a comment. You said next week, it's the week after, just saying that in case people wanted to send you something next week.
Yes, send me something next week and I give the talk the following week. Wednesday, December 12th is the talk. I know AGU starts the week after next, but there are all these extra meetings that are next week, so that's why I'm on the wrong week there. And then data management within the above campaign. I just have a poster, so if a lot of you I see on a daily or weekly basis, but if I don't and you want to come and find me, I'll be at the above poster session. Stop by and we can just chat about any kind of data related things. I'm always happy to do that. So I just wanted to mention those. And then again, if you have success stories you would like to share, either with me so that I can include them in my talk or on my poster, I would be very much obliged if you would send them my way. You can send me a slide, you can send me a picture with a sentence text or less, and I would be happy to include it. And then this comes up sometimes. I just want to remind users that if you do use the Above Science Cloud, please include it in your publications. And there's some kind of general language you can hear. Language written here. You can always change it for what works for you. Just like you should always be acknowledging above in all of your publications as well. There are places on our website where you can add in your publications, and you can add in your products that you create into our database. And when you add them in, you can also check there that you have used the Science Cloud to create them or used any of the high resolution imagery. So that's just a note. And then I'll open the floor up for just additional questions as well. I wanted to make note while we were here that, let's see, Jim mentioned to me before this call started that they've changed a little bit about the Science Cloud so that we should have stable and faster connections right now. I think we removed a network card or a...
Yeah, simplified some of the network connections, yep.
And now everyone, I think, should be using the ADAPT login node. I think the Digital Globe, or what was it called? NGA login is gone. So everyone should be using ADAPT login now. If you're not sure about that, you can email me, or you can always email support@nccs.nasa.gov. They're always more than happy to help. Any other questions?
Can you hear me now?
Yep.
Oh, hey, this is Matt. I have two mutes.
Hi, Matt.
Yeah. Anyway, that was some interesting stuff. I guess I learned better by actually trying it, and I wasn't sure if there was what is the best way to get into some that example Python interface for a remote user, to just try to take that for a spin.
Jim, do you want to share your screen again and show him how he would actually get into that?
Sure. Let me
okay.
Okay, so the way you would do it, are you already using Guacamole?
I have, yeah.
Yeah, so you go in through Guacamole, and you're going to be presented with the VMs that you have access to. I'll just pick one that I'm not logged into, right?
You do have to log in first, so Jim's already been logged in. So first you log in using your NASA LDAP, I think. Is that right, Jim?
It's the ADAPT LDAP, but they're simplifying that too. They're getting rid of that.
Okay,
so it'll be your NCCS LDAP account.
Yeah. Okay.
Okay, so once you get logged into Guacamole, you'll see your VMs. You just pick one of the VMs and log in. Oh, hang on. Let me pick a different one. No, I know what that is. I think that machine has been having a couple of glitches. So this is one I hardly ever use, so we're really going out on a limb here. All right. So every Windows VM has PyCharm installed. So you just open up PyCharm, and we'll give it a few seconds to load up. While that's loading, we'll come over here and look at the file management. So all of the Windows VMs have this shared drive. It's under C, ATT, Project, ArcShare. Let me see if I can copy that down for us here. Put it into the chat. Okay.
Oh, great.
All right, and then once you're into ArcShare Public, you can create a folder in here. All we ask is, if it's something like a team, then call it the team. So here's like the above folder. If it's something that you yourself are working on, just try and prepend your last name so that people know whose it is. But basically, these files are under this crobin2 directory under scripts. So I will copy that out as well.
What is this clipboard that you're using?
So this is the guacamole copy and paste through the browser. So I'm not sure what it is on Windows, but on Mac it's like Control Option Shift. And I have to give props to Julian Peters for teaching me that one. I did not know that. So he showed me how to do that. So it's Control Option Shift on a Mac. It helps you copy and paste between the environments. So so back to PyCharm. PyCharm loaded. Here you can see I actually have a different project loaded up. So let's close this project. All right, and then the great thing about PyCharm is that you can set these configurations. So if I come back to ATT project, ArcShare public crobin2, I'll go into that directory, and it gives me file management for the entire directory. But also, if you saved any configuration data in here, when you go to edit configurations, it'll be there, right? So that project has not closed on this other machine. It's still open here, which is why we're not seeing the edit configuration stuff. But yeah, you just run PyCharm and then go find the file that you want. And what happens is the very first time I go to run it, I'm just going to cancel it. Give it a second here. So it doesn't have any configuration set for these variables, so it probably should fail right away. Looks like this one may need to be configured a little bit differently. Oh no, here it is. It did. See, so it captured those settings from the other machine. So I can, let's say I don't want to do my sea ice concentration. Let's see, run edit configurations. But maybe I want to do a new one, right? I could actually put another one in here, and this next one would be temperature at surface, we'll say, or wind speed, or whatever it happens to be. We can just copy the configuration and change the parameters and run it, basically for different data sets. I think that's a pretty good explanation. Any more questions on how to get into PyCharm?
No, I'll give it a try.
All right, great. Let me know if you have any problems. It can be tricky to get going, but once you get going, it'll save you a ton of time.
Well, that's great. Thanks, Jim.
Hey,
any other questions? Oh, yeah.
So Liz, if I had trouble remembering that, like in a week or two, is there an easy place to like look this up?
Yeah, so I'll put in the chat box the link where webinars are going to be posted, and I'll try to get this one up. I could get it up today, or I can at least get it ready so it'll be up early next week. Let me link here. Here's the link where this will be posted. Also, I have the guacamole menu on Windows machines, and it's Control-Alt-Shift. On a Mac, it's Control-Command-Shift. So that's pretty helpful too. Any other questions? I see Go Iwahana has joined us as well. Go, I'm glad you could make it. Did you want to spend a minute or two talking about what you've been trying to do recently? Might not be able to hear Go, but I will say Go has been working on he's been trying to access to the digital globe imagery on the Science Cloud, and I've been trying to work with him to get it. So Go, I'll just say, oh, let's see, is he trying to chat here? Oh, Go cannot use the microphone. How do I make this go away now? You know how I make this go away, Jim?
You just press Control Shift Tab again. It should go away the same way you made it appear.
There we go. So Julian's been helping me with this as well. We've been trying to give me a list of 50 catalog IDs that he was looking for with NGA imagery, and here they are. And I was trying to help him find them. So Go, I'm still working on it. We've gotten, this is your study area, and this is the data set that you should use on the Science Cloud. So I'm in the Guacamole. I've gone in through Guacamole here, and I'm trying to find it for you. But this is the path for the data. You go to the P drive, and it's index, footprints, current. It goes all the way through here. So I'll keep working on this. If you have any specific questions, now you can chat them, or we can always talk offline about this too. But for all of you, if you have signed up to be a user of the NGA data, you can find that through the Windows machine or through the Linux machine. And if you ever have questions about that, you can send me an email and let me know. I personally like to use MOBA Extern to log on to the Science Cloud, and that is what this interface looks like. If you ever have questions, feel free to let me know.
And that was the footprints file you were pulling up, right?
That was just the footprints file, and then if you actually want the imagery itself, whoops, that's the wrong thing. If you actually want to get the imagery itself, you'd go into this footprints file, and there is a field in here which shows the O file path, which is the old file path, I think, and then the S file path, right, Julian, which is essentially the new file path?
Yes, S file path will be the path to the actual NIF file.
Yeah, okay.
Yeah. So
they're trying to stand up like an image service of some kind too, but I don't know how to find that.
So that's not quite ready yet. That's Chris Nye's project. He has a high-res imagery project, and they are working on a web service to make the imagery itself available so that people can come into the Science Cloud and view it. But it's not quite ready to go yet. Bill has a couple questions here. Do you have any tool to co-register all 60 images? And I know how to tell you how to orthorectify the imagery. Let me see if I can.
Yeah, I'm working with Chris Nye on that one project, and we're talking about the co-register issue a little bit, but the quick answer would be no.
Yeah, so
I mean,
what
but
you
if you
can
use
do,
if you use a DEM with the right vertical reference, you'll get closer on your initial ortho. So if you're seeing a big shift, that might be the issue.
So I'll send the link for this. There is a way to orthorectify imagery on the Science Cloud and it's been developed by the Polar Geospatial Center, and we have a little kind of there's a whole little user guide that's on the website you can use, and you can follow along, follow through there, and it works well to do that imagery orthorectification. But to co-register the images, we don't have I don't think an easy way to do that necessarily. Where's my chat box? There it is. So Matt, are you working to co-register images now?
Well, yeah, I guess I know I've run into issues, and I think that if you have to dive into the weeds a little bit on the DEM you're using to orthorectify that would be the first thing to do if you're seeing big shifts.
Mm-hmm. Okay.
Because most of the digital gold stuff actually should be pretty accurate, just based off of like the internal calibration. But if you have but it assumes that your DEM is referenced in a certain vertical reference frame. So, and many of the DEMs are not in that frame.
Okay. All right, Go. So we'll have to keep working with you on that one. We'll try to figure that out.
But yeah, I could, if Go wants to ask me for details, I could point him in the right direction.
All right. Thanks, Matt. All right. So any other questions? Maybe I will pull back up this document again. So I'll just remind everybody, stop by and come to the presentation, and please, if you have something you'd like shared about your work on the Science Cloud, I'd love to include your information in the talk or on the poster the week after next. So thanks everybody for coming. Thank you, Jim, for presenting. And I think the next one of these will be, we will not have one in December because it will conflict with, well, it will be after AGU, but it would be right before Christmas. So I think we will not have one in December. So probably in January we would have this again. So it would be January 18th. You can expect the next one. And if you have a topic you want to talk on, feel free to let us know. Thanks, everybody. Thanks, Jim.